In this video, we'll bend an accurate U-channel from outside dimensions using two formulas and a bend allowance taken from the machinery's handbook. The material is 063-inch 5052 aluminum, and the dies are 1/16-inch radius. Previous videos have covered installing a DRO and setting up my old Di-Acro press brake to make accurate bends. The simple U-channel shown here will form the basis for making other parts like a utility enclosure for electronic projects. The drawing shows an example 4-inch wide U-channel with 2-inch sides. It also shows the general formulas for making a U-channel of other dimensions. There is a link in the description to an index of all the press brake videos, threads, and drawings. Let's make a U-channel 3 inches wide with 1-inch sides. These would be outside dimensions. For this example, the length of the U-channel is arbitrary, so we can make that anything we want. No sense in wasting material, so I'll use 2 inches. The flat length L we need is expressed in terms of W, width, S, side or return length, BA, bend allowance, MT, material thickness, and BR, bend radius. The formula is shown. If we plug in the numbers and reduce the formula, our flat length is 4.774 inches. The bend allowance shown in yellow was taken from the machinery's handbook and has produced accurate bends for the conditions we're working with. We know our flat length is going to be 4.774 inches. The actual length of this U-channel is going to be arbitrary, so we won't worry too much about that. I made it 2 inches, so let's blank out a piece of 5052 here. Okay, so there's our 2-inch piece. I don't know if you can see this 4.774. Put a couple of scribe lines on here. Any inaccuracy in the length of this is going to show up in the width of the U-channel. Well, let's try to get this as close as we can. Okay, let's see what we got. All right, it's 4.773. I got lucky. 4.775. I don't know if you can see that or not. It's pretty close considering we did it by eye. Sometimes you get lucky. Take off the masking. And this is going to be our piece that will be bending. The next thing we got to do is figure out where our bends have to occur in from the edge. So let's do that next. The bend center BC is expressed in terms of S, side or return length, MT, material thickness, BR, bend radius, and BA, bend allowance. The formula is shown. Like before, plug in the numbers and reduce the formula to give a back gauge setting of 0.944 inches. The width of the U-channel is the material left over. If the blank piece is long or short of 4.774 inches, it will show in the width, assuming the returns are bent accurately. Okay, we got our blank piece of metal here. We'll fire up the press brake. Cycle the machine. Got our back gauge set. Let's go ahead and bend this, see what happens. Here's one return. Here's the other return. So here's our U-channel. Looks pretty good. Let's go take some measurements. All right, let's take some measurements. Do the returns first. We're a half a thousandth shy. on that. If you can see that, pretty good. We'll slide down a little bit. We're still within 1/1000th of an inch, so the edge is pretty square. Let's get the other return. So it looks like 1/1000th of an inch there. We'll slide down a little bit. Pieces out a square, a teeny little bit. Thousandths and a half. It's pretty good. It's an old machine. We'll go for the width, and we're crossing two bends here, so we're 3.5 thousandths, 3.5 thousandths, 2 thousandths, in and around in there. These bends might not quite be 90 degrees, so there might be a little bit of error introduced as a result of that, but it's an old machine. It's producing pretty accurate bends. Some conclusions we can draw for making accurate bends are summarized in the graphic. Make sure that your upper and lower dies line up. Back gauge is tight and accurate. Distance from the die's bend center to back face is accurate. Metal has been cut square and to proper length. Proper bend allowance has been used for bend conditions. Dies don't squeeze and displace metal during a bend. Math is done properly in the formulas. I hope this video has been helpful in going from theory to actually bending metal.